Today we will be looking at different type of digital images and some relationships of basic pixels. Don't forget to hit a like and subscribe, and if you have any comments or any suggestions or any questions, please leave them in the comment section below. I will dive right into the video. The different types of digital images are: number 1, intensity image. Intensity image intensity image can also be called a monochrome image, where each pixel corresponds to a light intensity normally represented in gray level. For example, in this small area, if this small area is zoomed, we can see that it contains a number of pixels. The number of pixels here can be represented as, for example, this one is 10, this one is 10, this one's 10, this one's 10, and then there are some values of 9, 6, 26 and so on, where each of these values represent grayscale values, where the grayscale values ranges from 0 to 255. Digital image, the second type is RGB image, which is a color image where each pixel contains a vector representing red, green and blue components. So, for example, this is the area of an image. When this is zoomed, we can see that this contains a number of pixels. For example, if we take this pixel will contain 99, 65 and 10. This means that each of them are a vector. It has a vector containing red, green and blue components. Each pixel is a vector containing red, green and blue components. The next is binary image, where each pixel represents one bit. 1 represents white, 0 represents black. Suppose in this example, this is the area that we want to examine. When enlarged, we can see that these are the corresponding pixels. Suppose this one corresponds to 0, 0, 0, 0. Because these are all black, so these all correspond to 0. Suppose this part, this corresponds to white, which is 1, 1, 1, 1 and so on. The next type of image is index image. Index image, each pixel contains an index number pointing to a color in a color table. Suppose this is the area. This area contains 9 pixels. For example, the first pixel is 1. What does 1 correspond to? 1 corresponds to index number 1, which contains 0.1% of the red component, 0.5% of the green component and 0.3% of the blue component. For example, let's take another one. Suppose this one. This one indexes to 5. This one contains 0.2% of the red component, 0.8% of the green component and 0.9% of the blue component. Now, can you tell me why we need an index image? If you know the answer, leave it in the comment section below. Now, we will be discussing some of the effect of spatial resolution and how pixels are related. This is an image which contains 256 into 256 pixels. This one contains 128 into 128 pixels. We can see that the image quality has degraded here. This one contains 32 into 32 pixels. This one has degraded so much that it's barely possible to understand what the image is. Here are some more examples of the effect of spatial resolution, but we will discuss them later when we come to this in our later videos. Okay, let us move on to the basic relationship of pixels. If this is the pixel xy, then the pixel next to this in the right direction is x plus 1, y. This one on the left is x minus 1, y. Above is x, y minus 1. Below is x, y plus 1. This one is x plus 1, y minus 1, x minus 1, y minus 1. This one is x minus 1, y plus 1, x plus 1, y plus 1. Can you tell me how this was indexed? If you can, please leave it in the comment section below. If not, I will explain it in my next video. Now, the neighbors of pixel. The neighborhood relation is used to tell the adjacent pixels. It is useful for analyzing regions. It might be confusing as to why we were bothering with this now, but I promise you this has a great impact on digital image processing. We will see this in our next videos, in the upcoming videos. For neighbor of P, if this is a pixel P, what are the four neighbors? X plus 1y, x minus 1y, x y minus 1, x y plus 1. The four neighborhood relation consists only of the vertical and horizontal neighbors. These are the vertical neighbors, these are the horizontal neighbors. 8 neighborhood of P. 8 neighborhood considers all the neighborhood relationships. So in addition to this horizontal and vertical pixels, it also considers the diagonal ones. X minus 1, y minus 1, x plus 1, y minus 1, x minus 1, y plus 1, x plus 1 and y plus 1. Now we can look at the diagonal neighbors of P. It eliminates the horizontal and the vertical components and only takes into account the diagonal neighbors, which are x minus 1, y minus 1, x plus 1, y plus 1, x plus 1, y minus 1 and x minus 1, y plus 1. Thank you for watching this video and I hope you've learned a lot.